Good day, grade 10 students. We are now on week number 7 for Science 10. But before we start with our new lesson for this new quarter, let us have first a prayer. Their containers. Okay, alam naman natin na kapag gas o hangin, wala silang shape, wala silang size, depende yung kung naasan sila nakalocate or nakalagay. Gases also have mass, o meron din silang mass or timbang, volume, temperature, and pressure. And these are all properties of gases which are essential in our study. Lahat ng properties ng gas, yung volume, o yung kanyang amount, yung kanyang mass or yung kanyang timbang, temperature, yung kanyang coldness or hotness, and the pressure. Okay? Volume is the amount of space occupied by gases. Yun nga, sabi nga sa inyo, yung amount o kung gaano kadami yung gases, yun ay tinatawag nating volume. Temperature is the measure of the coldness or hotness of the gas. Yun nga. Pressure is the force applied by the gas or particles per unit area. Yung puwersa na binibigay ng gases depende dun sa area kung nasaan siya. Gas particles have a very weak intermolecular force of attraction. Hence, they move as far as possible from each other. Diba kung naaalala ninyo, yung three characteristics of the characteristics of the three phases of matter. Pag sinabi natin solid, they are compact, the particles are they have compact particles, magkakadikit. Yun, dugtong-dugtong, walang gumagalaw, wala halos gumagalaw. Okay? Nare-recall nyo ba yung inyong studies during your grade 8 science? And then yung liquid naman, they are slightly separated from each other. Okay? Medyo nakakagalaw and medyo magkakahiwala yung particles. While for gases, they are very far from each other. That's why they can move freely because they have weak intermolecular force of attraction. Hindi sila madaling mag-attract sa isa't isa. So they move apart from each other. So these are the previous ideas na dapat alam nyo pa rin about the gases because it is essential, lalo na ngayon, na pag-aaralan natin yung ideal gas law and the kinetic molecular theory. Okay, so actually, this discussion will cover the different gas laws kung nasa normal class tayo. But since essential topics lang yung i-discuss ko sa inyo, kailangan pa rin naman natin na mapag-aralan or mapasadahan yung iba't ibang gas laws. Okay, so meron tayong iba't ibang gas. We have Boyle's Law, Charles Law, Gay-Lussac's Law, and Combined Gas Law. But for this video, you will only learn the summary of all the gas laws, which is the ideal gas law and the kinetic molecular theory. But let us run down each para meron din naman kayong idea and you can use if you will take up STEM subjects or science course during your college. Okay, so sa Boyle's Law, it characterizes or it identifies the relationship between the pressure and the volume of gas. Okay, so si Boyle's Law, ginawa siya ni Robert Boyle. Ang kanyang ina-investigate is the relationship between the pressure and the volume of gas. So sinasabi niya na kapag mas mataas ang pressure ng gas, kumukonti yung volume. Okay, kapag mas mababa naman yung pressure, tumataas yung volume ng gases. Okay, so balik ano siya, ang tawag dito, they are indirectly proportional. So pag tumaas yung isa, bababa yung isa. So ganun yung relationship between the pressure and the volume when it comes to Boyle's Law. Next one is the Charles Law. Okay, so Charles Law naman, it analyzes or investigates the relationship between the volume and temperature of gases. So, sinasabi ni Charles, yung scientist na gumawa ng Charles Law, kapag daw tumaas yung temperature, tumataas din yung volume or yung dami ng gases. So evident naman yan kapag nagpapakulo tayo ng tubig, di ba? So dumadami yung gas na nare-release kapag tumataas yung temperature or kapag nare-reach na yung mataas na temperature. And then kapag hindi pa ganun kataas na temperature, kaunti pa lang yung gases na mare-release. Okay? So example din yan yung sa may tawag natin yung Christmas lantern display, yung nilalagyan ng apoy sa ilalim, tapos nagre-release yun ng gas, lumalaki yung volume ng pinaka-balloon, kaya siya lumilipad. So, the explanation nun. So, dahil sa temperature ng apoy, dumadami yung gases na nagpapalipad dun sa balloon. Okay? So, parang sa hot air balloon lang din. So, yun yung evidence for Charles Law. Okay? Next one is the Gay-Lussac's Law. Okay? Yung Gay-Lussac's Law, it analyzes the relationship between pressure and temperature. So, like Charles Law, kapag tumaas yung isa, tataas din yung isa. So, kapag tumaas yung temperature, tumataas yung pressure. Okay? Kapag bumaba yung temperature, mababa lang yung pressure na nandun sa gas. And then, combined gas law, pinagsama-sama yung relationship between the pressure, volume, and temperature. So, let us have first a short simulation of this gas law para mas maintindihan ninyo. Okay? Now, let us use this simulation to show you the properties of gases. Okay? So, the container here will contain the gas and the pump there will bring particles inside the container. We have the pressure meter, which will count the number of pressure inside, and the temperature scale, which will determine the temperature inside our container. So, for example, I pump here the gases. Naglagay ako ng gas sa loob ng container. So, ano ba yung una nating mapapansin sa mga particles ng gases? Hindi sila nagsama-sama. Unlike sa water, pag nagpump tayo ng water or pag nagbukas tayo ng tubig, nasa isang place lang sila, sama-sama. Meron lang konting pagkakahiwalay, pero at ano naman, magsasama din sila kapag nakakuha na nila yung shape ng container. But for gases, they have weak intermolecular force of attraction, kaya sila ay naghihiwa-hiwalay. Hindi sila madaling mag-attract sa isa't isa. So the pressure reading here is 5.2 atmosphere or the unit for the pressure, and the temperature is 27 degrees Celsius. So ganyan siya. What happens when we add more heat? So itong ilalim para siyang stove na mag-heat. So for example, the temperature rises, what will happen to the pressure? Okay? So pressure will, so kanina ang pressure natin ay 5.2, tumaas siya ng konti, nagiging 6 na siya. So, tapos ano pa yung nangyari sa movement ng gases? Mas naging alive, parang mas gumalaw sila dahil sa dinagdag na heat. So, let's examine further. So, tinasan ko, ang temperature na nila ngayon ay 222 degrees Celsius. So, from 27 degrees Celsius, naging 222, tumaas yung pressure, naging 8 atmospheric pressure. Okay, so yun yung sinasabi ng isang gas na natin pressure temperature, yung Gay-Lussac. Okay, ganun din kapag tumataas yung volume, ay yung temperature, parang dumadami din yung particles ng gases. Okay? So, what happens when we add more gas? Tignan natin kung ano yung mangyayari. Okay. Dumami yung particles. Okay, tumataas din yung pressure. Yung particles yung pinag-uusapan na. So, dumadami yung pressure. What happens when we put naman cold temperature to the gas? Ano yung nangyayari? Ano yung nangyayari dun sa may pressure meter? Nagda-drop siya unti-unti. Okay, kasi mababa na yung temperature. And ano yung nangyayari sa movement ng gases? Yes, bumabagal yung movement ng gases sa loob ng container kasi nga nagpi-freeze din sila. So, ang temperature na nito ay nasa negative 200 degrees Celsius. So, imagine, ganyan yung temperature. So, unti-unti na bumabagal pero hiwa-hiwalay pa din yung kanilang particles. Tapos, yung pressure niya ay na 1.4, 1.4 atmosphere, 1.3 atmosphere, bumababa ng bumababa. Okay? So, ganyan lang yung relationship ng gas na kailangan ninyong matandaan. Okay? So, pagka yung pressure tumataas din yung temperature. Kapag yung temperature tumataas din yung volume. Kapag marami yung particles, tataas yung pressure. Okay? Kapag mababa yung temperature, mabagal silang gumalaw. Kapag mataas yung temperature, bumibil sila ng paggalaw. Okay? So, that happens, or those were the relationship of the different particles of the gases, or the different properties of gas, which are the pressure, volume, temperature, the particles, okay, and the temperature. So, lahat yan ay mayroong effect sa isa't isa. Okay, so what happens naman kapag sobra-sobra yung pressure? Tingnan natin So, tumataas na. So, 100 na yung pressure niya. Tingnan niyo yung pressure meter. And yung temperature niya is 500 na degrees Celsius. Okay. Kumawala. Ibig sabihin, ano nangyayari kapag sobra na yung pressure sa loob ng container? Diba? Diyan nangyayari yung mga sumasabog yung gases. Pag mataas yung pressure, temperature, and then nagkaroon na ng maraming particles, so pwede magkaroon ng pagsabog. Kaya nga yung mga gases, kasi naghahanap yan ng way out, kasi nga they are freely moving, hindi sila kaya makapag-compress. So kapag masyadong mataas yung temperature and yung pressure is ganun kataas, there comes explosion. Like sa LPG, di ba, nagkakaroon ng explosion. Yung nangyari dun sa may Beirut, sa may Lebanon, di ba? Napakalaki ng shockwave na ibinigay ng mga gas. Okay? So, let's move on or return to our slide. Okay, now na familiar na kayo sa basic properties of gases, let us now start with our main discussion for this video, which is all about the ideal gas law. Okay? The ideal gas equation is useful in illustrating the relationship among the pressure, volume, temperature, and the number of moles of a gas. This equation is used to describe gases that behave ideally. So, pag ba sinabi natin ideal, di ba? Parang yun yung pinakabasihan. Siya yung pinaka-angat, siya yung kumbaga archetype, or yun yung pag sinabi natin ideal boyfriend, di ba? Ideal girlfriend, yun yung gusto mo. Yun yung nakikita mo, yun yung top of the list mo. So, itong ideal gas law, siya yung pinaka nag-e-explain sa lahat among other gas law doon sa pinaka-behavior ng gases. Kasi nga, nandito na lahat. Nandyan yung pressure, yung volume, yung temperature, tapos yung number of moles. Or kung gaano kadaming particles yung nasa loob ng gas. Remember na pag-aralan nyo na yan during your science na, di ba? Mayroon kayong mole of a substance, yung mole to mass number, yung mga number of molecules na pag-aralan nyo na yan during your chemistry of grade 9 science. So ngayon, babalikan lang natin yan. Yung number of moles of a substance is the amount of particles or kung gaano kadaming particles yung makikita kapag ka pinaghiwa-hiwala yung isang substance. Okay? So what is the equation used in computing for ideal gas law? So for this gas law, the equation used is PV is equal to nRT. Yan. Ibig sabihin ng PV is equal to nRT na yan. Where P or the capital letter P stands for pressure, V or the capital letter V stands for the volume, and small letter n stands for the number of moles, R is for the universal gas constant 0.0821 liters atmosphere per moles in Kelvin. Okay, so hindi yan na mabago. Constant yung ating value ng R or the universal gas constant na 0.0821 liters atmosphere per mole Kelvin. Yung Kelvin na yan is the temperature. So yun yung letter T natin. Okay, di ba kasi meron tayong iba't ibang units for temperature. We have Celsius, Fahrenheit, Kelvin. Okay? Pero ang gagamitin natin sa mga formulas and solutions ay Kelvins because Kelvin is the constant or the universal unit for temperatures. Ibang bansa kasi may gumagamit ng Fahrenheit. Tayo, yung ginagamit natin ay Celsius. Kaya ang standard for science ay Kelvin para maging equal or pare-parehas yung maging computation. Okay, so let's try this with sample problem. Dito na darating yung ating computation part ng science. The only computation na kasi yung chemistry na tayo. So, example number 1. What is the volume of a container that can hold 0.45 mole of gas at 24 degrees Celsius and 1.23 atmospheric pressure? So, yan yung problem natin. So, mapapansin niyo meron na tayong tatlong given values. And then, yung isa pa na constant na universal gas constant. And ang hinahanap natin ay volume ng gas. Okay? So, the given values for these example problems are, we have the pressure which is 1.23 atmospheric or atmosphere. Volume, yung hinahanap natin. And then, yung number of moles or N is 0.45 moles. And then, yung R, universal gas constant, 0.0821 liters per atmosphere. Liters atmosphere per mole Kelvin. Okay, and temperature natin, again, kailangan natin siyang i-convert sa Kelvin. Paano ba mag-convert sa Kelvin ng degree Celsius? Lalagyan nyo lang siya ng additional na 273. So, 24 degrees Celsius plus 273, always yan, is equal to 297 Kelvin. So, yan yung ating gagamitin, hindi yung 24 degrees Celsius. So, ang ating formula, kanina pinresan ko sa inyo, is PV is equal to nRT. Now, paano natin makakompute na yung volume lang yung hahanapin dun sa equation na PV is equal to nRT? So, ganito. Ito laging tatandaan nyo. Para makapag-produce kayo ng new equation from the original formula, you will just have to cancel the values that are next to the missing values. So, paano ba yun? To get the value of V or the volume, you must derive a formula from our original formula by dividing the both sides of the equation to the variable that is near to it, which is the pressure. Okay, so diba ito yung original formula. Ang hinahanap natin ay volume. So para mahanap yung volume, kailangan lang tanggalin itong value na nasa tabi niya, which is the pressure. So we divide both sides of the equation to letter P. So divide both sides to letter P. So PV divide P, nRT divide P. So makakancel na yung P dito sa kabila. So ang ating bagong formula ay V or volume is equal to nRT over P. Okay, again, ito yung original formula. Kailangan ang matira lang dito is volume kasi siya hinahanap. So para matira lang yung volume, we divide both sides dun sa value na katabi niya, which is P. So, divide both sides to P. Makakancel na yung P dito. So, matitira ay V, yun. And then, matitira dito sa kabila yung nRT over P. So, So again, ang given values natin kanina ay we have P is equal to 1.23 atmosphere. Ang N natin ay 0.45 moles. Ang R natin di na mabago, 0.0821 liters atmosphere per mole Kelvin. And then yung temperature natin, yung na-derive na 297K. So applying this to our formula, V is equal to nRT over P. So V is equal to yung N, sa substitute lang natin yung 0.45 moles. And then yung R is 0.0821 liters atmosphere per mole Kelvin. Okay? And then yung T, 297 Kelvin. Divide it to the pressure. Amount of pressure is 1.23 atmospheric pressure. So, i-cancel na natin lahat ng pwede i-cancel. Yan, yung mole, may mole dito, cancel. ATM dito, may ATM din dito. May K dito, may K din dito. So, cancel, 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 cancel. Para matira na lang liters. Kasi nga, volume yung hinahanap natin. So, kailangan liters yung makuha natin. So, pag mumultiply nyo lang itong tatlo na to, 0.45 times 0.081 times 297, and then divide nyo yung makuha ninyong product sa 1.23. Okay, so 0.45 times 0.081 times 297 is equal to 10.97 liters. Divide it to 1.23. The quotient is our final answer, which is 8.92 liters. And that is the volume of the gas, which has 1.23 atmospheric pressure and consists of 0.45 moles under a temperature of 297 Kelvin. Okay? So, let us have another example. A sample of liquid acetone. Okay, so sino ba dito gumagamit ng liquid acetone? Pang-remove ng nail polish, I guess, is placed in a 0.023 liters flask or lalagyanan and vaporized, pinainitan, pinakuluan by heating it to 80 degrees Celsius at 1.05 atmospheric pressure. The vapor weighs 5.88 grams. Calculate the number of moles of the acetone. So, ang hinahanap natin dito naman ay moles or amount of particles inside the liquid acetone. So, we have the given values. Pressure is 1.05 atmosphere. Okay? Volume is 0.023 liters. Number of moles, the missing. R, hindi na mabago, 0.081 liters per atmosphere per mole Kelvin. Temperature, 80 degrees Celsius. Always dadagdagan ng 273 yung temperature. Kaya ang magagamit natin ay 353 Kelvin. Okay, nasusundan pa kaya? Okay, so kinuha lang natin, breakdown lang natin yung given values. Now, how can we solve this using our formula? Ang hinahanap natin ay N. Ano yung katabi ng N dito sa ating original formula? So, ganun lang din, kailangan tanggalin kung ano yung katabi ng N. Katulad ng ginawa natin sa unang problem. So, to get the value of N, you must derive a formula from our original formula by dividing both sides of the equation to the value that is near to it, which is the RT. Okay? So, we have PV is equal to nRT. Divide both sides to RT. Maka-cancel na yung RT dito. Therefore, our new formula will be N, or number of molecules, is equal to PV over RT. Ganun siya. Kung sino yung nawawala, titignan mo kung ano yung katabi niya, then ika-cancel mo yon by dividing it to the both sides of equation so that it will remain on the other side of the equation. So now, we can apply the formula to the given values. So we have again, ang given values natin ay 0. Pressure is 1.05 atmosphere. Volume is 0.023 liters. Hinahanap natin number of molecules. R is constant 0.02821 liters atmosphere per molecule Kelvin. And then temperature natin yung na-derive na 353 Kelvin. So yung formula natin na bago, N is equal to PV over RT. So we have P is equal to 1.05 atmosphere, V or volume 0.023 liters, R is equal to 0.0821 liters atmosphere per mole Kelvin, and then yung temperature 353 Kelvin. So we have to multiply both up and the upper side and the lower side of our equation. So multiply lang natin 1.05 sa 0.23. So ang lalabas doon ay 0.024. By the way, you can cancel all the similar units. We have atmosphere, cancel. Liters, cancel. Kelvin, cancel. So para matira na lang yung moles. Dahil nga, number of moles yung hinahanap natin. So again, 1.05 times 0.023 liters is equal to 0.024. And then, 0.081 times 353 is equal to 28.98 moles. Kasi nga yun ang natira. Then divide 0.024 to 28.98 moles. The final answer will be N is equal to 0.00083 moles. But in science, report it in significant figures. Hindi tayo nagsasagot ng 0.000 yung mahaba or 80000. Ginagawa natin, kinukuha natin yung scientific notation para matira lang yung significant figures. Okay? So, paano ba kumuha ng scientific notation? So, move lang natin yung decimals hanggang makarating siya sa isang number na greater than 1 or 1 or more. Okay? So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, move lang natin. So, 1, 2, 3, 4. Hanggang makarating siya sa unang digit na 1 pataas. So, pasok tong 8. So, magiging 8.3. Tapos, lalagyan nyo lang siya ng times 10. Then, negative 4. Saan nakuha yung negative 4? Dahil nag-move tayo ng 1, 2, 3, 4 to the right, maglalagay tayo ng negative to the right kasi yun. And then, yung 4 ay kung ilang beses ka nag-move ng decimal. So, that will be our final answer. 8.3 times 10 raised to negative 4 moles. And that is the number of particles inside this gas under pressure of 1.05 atmosphere with a temperature of 80 degrees Celsius having a volume of 0.023 liters. Okay? So you may check also in your calculator if the calculations are correct. Just use a scientific calculator. Okay? So that's it for our ideal gas law. Now let us sum up all those ideas in what we call the kinetic molecular theory. Para saan ba? Ano ba ang sinasabi ng kinetic molecular theory? Kinetic molecular theory or the KMT explains the properties of gases and describes the behavior of gas. All of these properties, pressure, volume, temperature, amount of particles, are described and explained by the KMT or the kinetic molecular theory. Okay? So let us first discuss the first explanation. Gases are composed of molecules or the number of particles. Alam naman natin yan. The distances from one molecule to another molecule are far greater than molecules' dimensions. These molecules can be considered as spherical bodies which possesses negligible mass and volume. So, yung mga gases daw ay nagko-compose of na mga molecules that are spherical in shape. Pinakita ko sa inyo kanina doon sa ating simulation na meron niyang ganong particles yung ating gases. Although hindi natin sila nakikita by our naked eye. But when we analyze them, di ba, yung mga properties ng gas, makikita natin that they are composed of different molecules which are far greater from each other because they have weak molecular attraction. Number 2, gases are always in constant random motion and they frequently collide with one another and with the walls of the container. Collision among molecules are perfectly elastic, that is, energy may transfer from one molecule to another molecule as the result of collision, but the total energy of all molecules in the system remains the same or constant. Yan, napakahaba. Okay, so mapapansin nyo dun kanina sa simulation na pinakita ko sa inyo, merong random motion, iba-iba yung galaw ng gases, pero mapapansin niyo kapag tinaasan yung heat, constant siya na mabilis. Parang magkakamukha lang speed nila, pero iba-iba lang ng direction. Pero kapag binabaan yung temperature, mabagal sila, and same yung bagal nila. Walang mas mabagal to, ito pinakamabagal, wala. Ang magkakaiba lang sa kanila is the direction kung saan sila pumupunta. They are also perfectly elastic. Kung naaalala ninyo yung studies ninyo sa grade 9 science, yung law of conservation of momentum, the different types of collision, yung isa na nga doon yung perfectly elastic, na kapag yung isang particle ay bumunggos isang particle, matatransfer niya yung energy dun sa isang particle, kaya yung energy sa kabuuan ng mga molecules na yun ay hindi nawawala, kundi na ipapasa lamang sa isa't isa. They are conserved. Okay, so that is for number 2. Next, there is neither attractive or repulsive force between or among gas molecules. Walang nag-a-attract, walang nagre-repulse. Okay? Pwede sila magbungguan pero hindi sila mag-a-attract, magdidikit. Hindi rin sila yung parang papalapit isa, lalayo isa, parang sa mga magnet. Because gases move directly away from each other in random motion, walang repulsive force, walang attractive force. Walang nagpupush, walang nagpupull or nagdidikit. Okay, so walang attractive or repulsive force, just like the magnets. And lastly, movement of gas molecules is affected by temperature. Tama naman, di ba? The average kinetic of the molecules is directly related to the temperature of gas. So, pakita ko na kanina sa inyo sa simulation, kapag tinataasan yung temperature, directly affected yung gas. Dumibilis yung kanilang kilos. Kapag binabaan ko yung temperature, ay directly affected din yung gas. Bababa din yung kanilang motion. Babagal sila. Okay, so that is for kinetic molecular theory. So to sum up all of the discussion, so far you have learned that gases have mass, volume, temperature, and it exerts pressure. The pressure exerted by gas molecule is due to the collision among gas molecules and with the walls of the container. So yung pressure o yung puwersa dahil yun sa kanilang pagbubungguan, collision, saka dun din sa container kung asan sila. Kapag bumunggo sila dun sa container, nagkakaroon ng pressure. Okay? The frequency of collision is affected by temperature because gas molecules move faster at high temperature. On the other hand, move slowly at low temperature. Okay, so ulit-ulit ko nang nasabi yan, na kapag mataas ang temperature, mataas or mabilis ang movement and vis-a-vis. Okay? The faster the movement of the molecules, the more frequent the collision, causing an increase in pressure. So kapag mataas, mabilis ang movement ng molecules, maraming collisions na nagaganap, maraming bungguan, tataas ang pressure. And kapag hindi na-contain, hindi napigilan, there will be a breach or explosion. Kaya nga napakahirap i-control kapag gases yung ating dinidil. Kailangan talaga they are kumbaga contained, kasi lalo na kung hindi safe yung gas, is magkakaroon ng widespread breach or explosion. Okay? So that's it for our lesson for this week, and that is all about the gas laws or the behavior of gases. If you want to learn more about our lesson, you can open the file on your flash drive named gas laws. It's time for you to take the assessment. Answer activity 2 to 3 on the assessment sheets. For activity 3, that is your mini task. You will perform an experiment that will show the behavior of gases. If you have questions, you can contact me during our consultation time. Submission of this LP will be on Monday, and as well as the assessment, because LP6 and LP7 is magkasabay yung tinitake, but different time yung assessment and submission. Okay? So I am leaving you with this values integration. Answer this values integration because it has equivalent points as well. Oxygen is the most important gas present in our atmosphere that keep us alive. But since industrial revolution began, technologies are introduced, the different transportation modes are introduced which uses different gases that are harmful to our air. The air quality that we breathe degrade. What green and feasible actions can a student like you do to halt our pollution?